Prism. So today we'll see the part of geometric optics which is connected with the concepts of prism. Okay, so first we'll see what is a prism concept first. Always a prism is not like this a triangular shape, any object or any made up of any glass or any other materials. It is not like this. Okay, so that means you can say prism is a concept first. How it is? Just think. When light travels from a medium to another medium, what will happen? We know. Let this is normal. Light is falling from this is rarer medium. Let this is denser medium. Everybody knows will go towards the denser medium. Everybody knows towards the normal. It bends towards the normal. Again, when this will come out of this, it will go away from the normal parallelly. So this two ray, this ray and this ray are parallel to each other. Okay, you know these things. Okay, so now these two surface, this surface and this surface, these are parallel to each other also. These two refracting surfaces are parallel to each other, but always light doesn't meet with the parallel surfaces. It may also meet two unparallel surfaces also. When light meet two unparalleled surfaces, there may be the application of the concept of prism. That's why I can say a simple prism is a homogeneous transparent refracting medium. Homogeneous transparent refracting medium bounded by at least two non-parallel surfaces inclined at some angle. ये प्रिज्म का कॉन्सेप्ट फर्स्ट थिंग. दैट मीन्स प्रिज्म ऐसा नहीं है कि ऑलवेज एक ट्रायंगुलर ऑब्जेक्ट होगा, ऐसा कुछ जरूरी नहीं है. ओके, दैट मीन्स लेट यहाँ पे रे इंसिडेंट हुआ, द इंसिडेंट रे. व्हाट इज इंसिडेंट रे? द रे व्हिच इज अप्रोचिंग टुवर्ड्स द रिफ्रैक्टिंग सरफेस. तो इधर जाना चाहिए था. दिस वाज इट्स ओरिजिनल पाथ. तो जस्ट draw a normal here. Let this is denser, this is let a rarer medium. The ray will bend towards the normal. Again it should go along this direction, but again draw a normal, it will go away from the normal like this. Okay, now this surface and this surface are the refracting surfaces, and these two surfaces made or inclined at some angle. They are not parallel. That's why you can say this is a prism here. Very much similar. Ray can do here also like this. Here also. Okay, here also like this. Here also like this. Okay, here also it can. So all these are based on the prism concept. That means you should be careful about the two refracting surfaces. You should be careful about the two refracting surfaces. If these two refracting surfaces are not parallel to each other, then prism concept you can apply. Clear? So what will happen in case of a prism actually? So before that, you should know the relation of mu, the refractive index. What is mu? Refractive index relation of it with wavelength of the light. So there is a relation like this, some constant A, B by lambda square C by lambda to the power 4, like this expression. What I usually write the first two terms, B by lambda square. This formula is known as, remember, CAUCHY'S formula. ये भी कभी कभी एग्जाम में आता है, खाली CAUCHY'S formula क्या है? A and B are some constants. A, B are the constants. Lambda is the wavelength. So from this relation, you can say if lambda is more, mu is less. So you know Behavior. You all know about Behavior. So you can say lambda of the red light is more than lambda of violet. From this you can say mu for red light is lesser than mu for violet. Can you conclude? What does it mean? That means वही मीडियम सेम लेट हम जो कहते हैं ना ग्लास का म्यू 1.5 वाटर का 4/3 एक्चुअली वो एक मीन है. ओके ये जो हमारा जो विजिबल लाइट है ये विजिबल लाइट का स्पेक्ट्रम है, विजिबल लाइट है. ओके ये विजिबल लाइट का एक मीन है, मीन म्यू है. नहीं तो रेड लाइट का म्यू अलग होगा, वॉयलेट लाइट का म्यू अलग होगा, हालांकि उतना डिफरेंस नहीं है. हाँ अगर किसी का म्यू ज्यादा है तो क्या कहने की कोशिश कर रहे हैं? इफ एनीबॉडी हैज म्यू लार्जर, व्हाट डज इट मीन? अगर म्यू ज्यादा है, लाइट बेंड्स मोर टुवर्ड्स नॉर्मल. हाँ कि नहीं? देखो कैसे, आई विल शो यू नाउ. So let this is a refracting surface. This is normal. Let a ray falls on it. This is the surface. This is the medium, different medium let. This is the incident ray. Let this is I. Just think it is a white light. Okay. Just think about the two extreme colors, that is red and violet. So I can now write, let this is air, this is some other medium. 1 sin I. For red I will write mu r sin theta r. Similarly I can write for violet 1 sin I mu violet sin theta violet. Yes or no? तो फ्रॉम दिस टू यू कैन कंक्लूड इजीली. देखो इधर जो चीज है इधर भी वही है साइन आई. इजीली यू कैन कंक्लूड थीटा वायलेट विल बी लेसर देन थीटा आर बिकॉज म्यू वायलेट इज ग्रेटर देन म्यू आर. दैट मीन्स देयर इज सम कांस्टेंट. हमारा जनरल इक्वेशन क्या होता है? 1 sin I म्यू इंटू साइन आर. ये तो होता ना. अगर ये वैल्यूज हमारा सेम है, अगर म्यू इंक्रीज हो रहा है ये टर्म डिक्रीज होगा. तो डिक्रीज होने के लिए आर को भी घटना पड़ेगा, क्योंकि आर अगर घटेगा तो साइन आर का वैल्यू भी कम होगा। क्लियर? तो जिसके लिए म्यू ज्यादा, वो एंगल कम करेगा, इट विल मोर बेंड टुवर्ड्स द आर कॉमन। छोटा मतलब क्या है? आर लेसर, व्हाट डज इट मीन? इट बेंड्स, द लाइट बेंड्स टुवर्ड्स द light bends towards the normal, making the angle smaller, making the angle smaller. Clear? So now I can draw the diagram. Violet in this one. Exact violet we can't have here. So मान लेते हैं ये violet and red. Red will be like this. Okay. Other colors also. Blue, green, 7 colors. Yellow, orange, okay, 7 colors are like this. This splitting of different colors, this is known as splitting of this different color is known as dispersion of light. Splitting into different colors is known as dispersion. Full detail study, we'll study detail about dispersion in another video. So what will happen when there is a plane surface, plane parallel surfaces? Let this is a normal, light is being fall and it like this. Okay, so violet light will come like this, and the red will almost like this. After that, we know they will go parallel to the incident ray. They will go parallel, that means like this. So there is a question in mind, sir, if this is white light, we should observe here different colors, but it is not like that. Why? Because I have drawn a single ray here, but in practical cases we can't differentiate a light beam into different rays. हम एक एक रे करके नहीं कर सकते. Okay, there are many rays. Okay, there are many rays. Let there is another ray. another parallel ray like this, huh? And here also splitting it into different colors. Different colors like this. So all these rays will reach to our eye. When all these rays mix up, it will again white. Remember, this is maybe a question also. This is white, not this is colored here. This is white, important. But what will happen in case of prism? We'll see now. Let this is the prism. Let white light is being fallen on of its surfaces. This is normal. This should go in this way. But according to Snell's law, it will go like this. This is violet. This is for red. This is for red. This is for violet. Okay. Again, normal are this. Draw the normals. Draw the normals. We'll go away from the normal. Will deviate. Red will deviate less because for it mu is less. Other colors also in between these things. So here, take another ray. You can test here also. If you take another ray like this, if you take another ray, what will happen? It will also show like this. It will go. Okay. So here red. In the upper section, it will be red. Like this. So you can see here in the upper part is red. In the lower part, here violet or blue, whatever it can be. बट व्हाट विल हैपन हियर, देखो यहाँ पे तो मिक्सड अप है, यहाँ पे देखो रेड वायलेट मिक्स है, ऐसे भी ऊपर में रेड वायलेट मिक्स हो जाएगा. तो हियर रेज कैन सेपरेट स्प्लिट आउट, बट हियर डू नॉट. केस ऑफ स्लैब इट कैन बी, बट इन केस ऑफ प्रिज्म इट. So prism have the ability to separate a white light into different colors. Okay. So we should know some terminology about the prism. Sorry. So here रिफ्रैक्टिंग सरफेसेस इसको कहते हैं, रे जाके जो दोनों सरफेस को टकराएगा। अब ये पहला सरफेस है, दिस इज द सेकंड वन, दिस टू सरफेसेस आर नोन एज रिफ्रैक्टिंग सरफेसेस एंड एंगल मेड बिटवीन देम इज एंगल ऑफ प्रिज्म। और कभी कभी ये सेंटेंस भी लिखा जाता है रिफ्रैक्टिंग एंगल ऑफ प्रिज्म भी लिखा जाता है क्वेश्चन, बी केयरफुल फॉर दैट। ओके, दैट मीन्स एंगल ऑफ प्रिज्म किसको कहेंगे? लेट ये तेरा प्रिज्म है, एक रे गया, वो कुछ जो भी तुम्हारा बिहेवियर दिखा रहा है दिखा है, ये ए बी सी, ये जो रे मैंने ड्रॉ किया है इसके लिए एंगल ऑफ प्रिज्म ए बनेगा, ये बनेगा। लेट मेरा रिफ्रैक्शन यहाँ पे हो रहा है, ये ग्रीन वाला जो देख रहे हो ऐसा है, तो ये ग्रीन वाला ये सी, इसके लिए एंगल ऑफ प्रिज्म ये बनेगा। समझ में आया? तो जो दोनों सरफेस रिफ्रैक्शन कर रहे हैं, द एंगल मेड बाय दिस टू सरफेसेस आर नोन एज योर एंगल ऑफ प्रिज्म। ओके, now come to the part deviations. What do you mean by deviation? सिंपल कम टू द लिटरल मीनिंग और इंग्लिश मीनिंग ऑफ डेविएशन, भटकना। अपने रास्ता से जो भटक जाता है डेविएट हो जाता कहता है कि नहीं। तो लाइट अपने रास्ते से कितना भटकता है, कितना चेंज हो जाता है, रास्ता कितना चेंज करता है, कौन सा डायरेक्शन में, कितना एंगल में, दैट इज डेविएशन। यू विल सी नाउ। मान लेते कोई मोनोक्रोमेटिक लाइट, स्टडी करने के लिए आसान होगा, एक ही कलर का है, ए बी सी, एंगल ऑफ प्रिज्म लेट ए है, यहाँ पे एक नॉर्मल खींचते हैं बेटा। तो दिस वाज इट्स ओरिजिनल पाथ, बट it will go towards this, towards the normal. Again, this is the normal to this surface. Again, it will go away from the normal. Clear? तो देखो this angle is I, angle of incidence. This angle is let R1. This angle is R2. This angle is emergent angle. I is the angle of incidence, R1, R2 are the refraction, angle of refraction, E is the emergent angle, and I is the angle of prism. Angle of prism. I, you know, angle of incidence, R1 and R2 refraction angles or angle of refractions, and E is the angle of emergence or emergent angle. Deviation is usually represented as delta change. देखो, this was the original ray first. Here it has been deviated some angle, this green one, let delta 1. Again here the second refraction, it is going in this way, but due to this surface It is being deviated through this much angle, delta 2. So net deviation, delta 1 clockwise plus delta 2 clockwise. So this is clockwise. As clock rotates in this direction, this is clockwise. Along this direction, anti-clockwise. So here delta 1 and delta 2 both are clockwise direction deviation. Simple add it. We'll find the answer. So now we'll check. Okay, how to find out this. देखो, delta 1 first. Easily you can say, if this is I, this total angle, just a minute. This total angle is also I. So from here you can write delta 1 is equal to I minus R1. Similarly, delta 2, if this is R2, this is R2. Total is E. So from here you can write delta 2 is equal to E minus R2. So simple add it. Both direction are same, तो simple add. ये भी clockwise है, ये भी clockwise है, तो direction दोनों का same है. Nothing to worry about it. Directly add them. I plus E minus R1 plus R2. This is one formula. Next, come to next part. I'm naming, so let this point is M, this point is N, this point is O. You can see the quadrangle AMON. So M and N angle are 90 degree to each other. These are 90. This is 90. Yes. So from here you can write angle A plus O plus both 90 and 90 180 equal to 360. So from here you can write A plus O is 180. Similarly in the triangle MNO, O plus R1 plus R2 is 180. From these two, this and this, easily you can conclude A must be equal to R1 plus R2. This is one relation, very important relation. Put here. Now we'll get delta equal to I plus E minus A. Very important relationship. Very important. Okay. So this is the general case. So directly you can use this formula in most of the cases. I'm not telling in all of the cases. In most of the cases, usually in your exam, in particular in NEET, almost you can find the result by using this formula. But there may be some questions where you can't find directly by using this formula. Okay, by using this formula directly you can find the deviation, or you may get reach into a wrong answer also. How? Check now. Some examples. Let this is 30 degree. just a minute. Don't take 30. Let it is 15 degree. Let this angle is 15 degree. Let there is a grazing incident happens. Let this is root 2. Its refractive index is root 2. Let now we'll see what will happen. Okay. So this angle is 90. Now I can write 1 sine 90 degree root 2 sine r. So r equal to 45 degree. You can easily calculate 45. That means this ray 45 degree. Okay. 45. So this is 45 also. This angle is 45 degree. Now this is 120 degree. Just look what will happen in this region. Okay. In this region, angle is this. The red, the light falls here. This is 15 degree. This is 45 degree. Obviously, this will be how much? 120 degree. Now draw the normal here. Draw normal here. Okay. If this is 90, it will be 30. Now root 2 sine 30, 1 sine e. So e equal to also 45 degree. That means the first case, देखो, in the first case, what will happen? This is a very good example. In the first case, the light is being deviated through an angle delta 1 that is 45 degree anticlockwise. Yes. Now the light original path is this. So if this is 30, obviously this is 30. Now emergent angle is 45. That means it will go 15 degree anticlockwise. क्योंकि 45 है. This total angle is 45. Now this is 30 means this will be 15. 15 degree anticlockwise. Net deviation here 45 degree anticlockwise plus 50, sorry, anticlockwise है क्या यहाँ पे? This is clockwise ना? Yes, clockwise. Sorry, clockwise plus here 15 degree anticlockwise. So on a net एक पॉजिटिव मानेंगे तो दूसरा नेगेटिव मानेंगे, तो 30 डिग्री कौन ज्यादा रहेगा? क्लॉकवाइज। 30 डिग्री क्लॉकवाइज द नेट। तो इन द एग्जाम हाउ डू यू फाइंड इट आउट? एग्जाम में तो वैसे तुमको पता नहीं चलेगा फटाक से। देखो, हमने लिखा था ए इक्वल टू R1 प्लस R2। R1 तो मिल जाएगा यहाँ से 45 डिग्री हुआ। R1 कितना हुआ? 45 डिग्री हुआ। ए कितना दिया है? 15 दिया है। तो R2 -30 आ रहा है। तो अगर ऐसे नेगेटिव आंसर आ गया तो डोंट गो फॉर द फॉर्मूला, डोंट गो फॉर द फॉर्मूला, यू हैव टू कैलकुलेट लाइक दिस। इसलिए कहा मोस्ट ऑफ द केसेस में वो फॉर्मूला लगा सकते हो, कोई प्रॉब्लम नहीं है, बट इन सम क्वेश्चंस you may get trapped also. Clear? Another example I'm showing. That there is an angle of incidence 60, that is √3. Now what will happen? Monochromatic light. Obviously you can apply. Here also, देखो, n is given, angle of prism is given, I is given. So you cannot directly derive here. Okay, ये क्या ऑब्ट्यूस एंगल है? ऑब्ट्यूस एंगल जब होगा थोड़ा चेक करना पक्का, 90 से ज्यादा है, थोड़ा चेक करना। तो देखो क्या होगा, 1 sin 60 √3 sin R1 है। ये √3/2 तो R1 हो जाएगा 30 डिग्री। यहाँ पे गलती होने के चांसेस है। दैट मीन्स अगर 30 डिग्री तू ऐसे ड्रॉ कर दिया, ये 30, ये 60, तो 150 + 60 210, ये ट्राइंगल में 210 डिग्री कैसे होगा? तो ये वाला लाइन नहीं हो सकता, ये गलत है, दिस इज रॉन्ग वन। तो हाउ दिस रे विल कम? देखो कैसे होगा। दिस रे कम लाइक दिस, 30 डिग्री मतलब यहाँ पे कहीं जाके लगेगा, दिस इज 30 डिग्री, दिस इज figure 16 also. Clear? Now 15, this is 30, this is 90. Obviously this will be 45. This is 45, this will be 45. Now I can put the formula here. √3 sin 45, 1 sin R, √3/√2 sin R. दिस वैल्यू इज ग्रेटर देन 1, नॉट पॉसिबल। साइन का वैल्यू 1 से बड़ा नहीं हो सकता, तो यहाँ पे इंटरनल रिफ्लेक्शन होगा, इट इम्प्लाइज टोटल इंटरनल रिफ्लेक्शन। So this ray will go like this, 45 angle, at 45 degree angle like this. So this is 45, again 60, again same thing will happen. If this is 60, 120, 90, this angle will be again 30, like this. So 30 root 3 sine 30, 1 into sine e. E equal to again 60 degree. Which is normal 30 like this. Okay, now calculate the delta here. In the first case, delta is this one. Again, here delta 2. Again, delta 3. यहाँ पे डेल्टा कैसे लिखेंगे? फर्स्ट डेल्टा कितना हुआ? 30 डिग्री क्लॉकवाइज इधर, देन 90 डिग्री देखो यहाँ पे इधर जा रहा था, इधर जा रहा है, ये एंगल कितना हुआ? 90, तो 180 माइनस 90, तो 90 डिग्री एंटी क्लॉकवाइज, फिर 30 डिग्री क्लॉकवाइज। तो नेट पे क्या बच गया? 30 30 60, 30 डिग्री एंटी क्लॉकवाइज। इस द नेट डेविएशन। समझ में आया? Be careful when solving the questions. फटाक से do not jump into the conclusions. Clear? Next, come to part of thin prism. ये जो thin prism का concept है, here all the angles are very thin, or that means angle of prism is also very thin. That means this angle is almost up to 4 to 5 degree in your questions. In practically, this is 4 to 5 degree. And here angle of incidence, everything is very small. Okay, the angle of incidence, angle of emergence, all angles are very, very small here in case of thin prism. Remember it. Okay, just think when a light ray falls on it at some angle I, which is very thin. Okay, one can write 1 sin I mu sin R1, I equal to mu R1. Again, you know A equal to R1 plus R2. You know this thing. For the second diffraction, you can write mu sin R2, 1 sin E. So mu R2 is equal to E. So now you have I and E. Easily you can write by putting the formula delta equal to I plus E minus A. So I is this one, E is this one. A. The formula will be mu R1 plus R2 minus A. R1 plus R2 is A. So mu minus 1 into A. So here you can conclude, in case of thin prism, delta doesn't depend on angle of incidence. For small angles, remember. So this is the formula. Many questions are being asked regarding this formula. Yeah. So in the next video, we'll show for a different angle of incidence, we will find different angle of deviation. So we will find out a relationship between this delta and I in the next video, and and we will see what are the condition for the minimum angle of deviation, when this angle will be minimum, when this angle will be also maximum, and what are the condition when all the ray will pass throughout the second refracting surface, or no ray will pass out the second refracting surfaces. Okay, dispersive power, dispersion in the next video. Up to this one part of the video completed. So in this video, what we have learned, that basic idea about a prism. What is a prism? Why the light is being split when white light is falling on the surface of a prism? Why it splits into different colors? So these are the concepts, and there we got a general formula for delta. For the most of the cases, you can apply this formula also. Clear? But we should know about all the concepts, how delta is being calculated. Thanks.